Hello dears, hello grade 9 students, hello everybody. Today we will talk about light energy. We will talk about mirrors. This is chapter 2 in your curriculum. Mirrors is a very interesting topic. Here we will talk about lesson 1, mirrors. If you stand in front of a mirror, you can see your image. This image is formed due to the light reflection. As you see here, if you stand in front of a mirror, you will see your picture, your image here in the mirror. Why is that? This is because of light reflection. What is light reflection? It is the phenomenon of the light bouncing off in the same medium when it meets or strikes a reflecting surface. When the light falls on your body and then strikes the reflecting surface, it will form an image as you see here in the mirror. We have two types of mirrors. We have plane mirrors and spherical mirrors. The spherical mirrors divided into concave mirrors and convex mirrors. The plane mirrors. When we stand in front of a plane mirror, we see our image. This image have specific properties. Please note that the image will be erect, upright. As you see here, the image is upright. This is the original body and this is the image. As you see here, head up and pull down. Upright, erect. Number 2, the image will be equal to the object. As you see here, the object size and the image size are equal. Number 3, the image is laterally inverted or reversed. As you see here, the pole here is laid to the left side, here to the right side. So it is laterally inverted, and the letters here ME, as you see here, EM. So the image laterally inverted or reversed. The image also in the plane mirror will be virtual. What is meant by virtual? Virtual, it means there is no chance to receive it on a screen. There is no chance to receive it on a screen, so it is virtual. Virtual. Number 4, the image is virtual. Number 5, the distance of the object to the mirror equals the distance of the image to the mirror. As you see here, the distance between the object and the plane mirror equals the distance which is in between the plane mirror and image. The two distances are equal. Number 6, the straight line connecting the object and its image is perpendicular to the surface of the mirror. The straight line here perpendicular on the plane surface. Okay, so 6 properties in the image which is formed in the plane mirror. The image is erect or upright. The image is equal to the object. The image is laterally inverted or reversed. The image is virtual image, not received on a screen. The distance between the object and the mirror equals the distance between the image and the mirror. Also, the straight line connecting the object and its image is perpendicular to the surface of the mirror. This is the properties, or these are the properties of the image which is formed in the plane mirror. What about light reflection? When a ray of light strikes a reflecting surface or a mirror, it is reflected in the same medium as shown in the figure. Please note this. Here is the light source, and this is the reflecting surface. When the light source sends its rays on the reflecting surface, strikes the reflecting surface, it rebounds off again in the same medium. Here is in air, or in the medium here, and give a reflecting ray. The light ray which comes from the light source to the reflecting surface is called incident ray. It makes an angle with the imaginary line which will be drawn here perpendicular to the reflecting surface, which is called normal, make an angle which is called angle of incidence. Then when it strikes the reflecting surface, it reflects again in the same medium and make a reflected ray. The reflected ray make also with the normal line an angle which is called angle of reflection. So here is incident ray, reflected ray, angle of incidence, angle of reflection, and in between, perpendicular on this reflecting surface, the normal, which is an imaginary line perpendicular on the reflecting surface. The incident ray is defined as, it is the light ray that falls on the reflecting surface. So, as you see here, the light ray which falls on the reflecting surface. The arrow direction, as you see, toward the reflecting surface. Number 2, the reflected ray defined as, it is the light rays that bounce from the reflecting surface. Here is the bouncing of the reflected ray from the reflected surface toward outside in the median. As you see, the arrow direction to outside. It is the angle of incidence. Angle of incidence, it is the angle between the incident light ray and the normal. As you see, here is the normal line which is perpendicular on the reflecting surface, and the incident light ray make with it an angle which is called the angle of incidence. So the angle of incidence, it is the angle in between the incident light ray and the normal. Finally, the angle of reflection. Angle of reflection means it is the angle between the reflected ray and the normal. Here is the angle of reflection. The reflected light ray with the normal make an angle which is called angle of reflection. Laws of light reflection. There are 2 laws of light reflection. Number 1, first law of light reflection states that angle of incidence equal angle of reflection. Angle of incidence equal angle of reflection. If we suppose that the angle of incidence here equal 50 degree, the angle of reflection will be also 50 degree. So the angle of incidence equals the angle of reflection. The second law of reflection is dependent upon the imagination. Please note this. The incident light ray and the reflected light ray and the normal line. Here is these 3 items. Is the incident light ray, the reflected light ray, and the normal. All, and the normal line to the reflecting surface at the point of incident, all lie in the same plane perpendicular to the reflecting surface. As you see here, if you imagine this is a plane surface, or the plane median is perpendicular on the reflecting surface median. So here is perpendicular on the reflecting surface. Incident light ray, normal reflecting light ray, plane perpendicular on the reflecting surface. This is the second light reflection law. So again, first law of reflection, angle of incidence equal angle of reflection. Number 2, second law, the incident light ray and the reflected light ray and the normal are all on plane perpendicular on the reflecting surface. This is for the plane mirrors. What about the spherical mirrors? Please note this. They are mirrors whose reflecting surface is a part of a sphere or a spherical surface. Please note this. This is a sphere. Here is a part of the sphere. The concave mirror, the reflecting surface here from inside, and the opaque surface from outside. What about convex mirror? The reflecting surface from outside and the opaque one from inside. So the concave mirror or the convex mirror all are part of this sphere. Part of this sphere. Despite of the reflecting surface which from inside or from outside. Types of spherical mirrors. Concave mirrors, which is called also converging mirrors. We will know why this name. Concave mirror, whose reflecting surface is the inner surface of the sphere, such as the inner surface of the spoon. Please note this, the inner surface of the sphere. In which of this? Concave mirror. The reflecting surface here, the inner surface of the sphere. Like the spoon from inside. From inside. We can make it practically in our home. As you see here, this part of the spoon like the concave mirror. The convex mirror, diverging mirror, whose reflecting surface is the outer surface of the sphere. As you see, the outer surface of the sphere is the reflecting one, as the back of the spoon. The back of the spoon. We must know this. Concave mirrors converge light rays that falls on its surface. Please note this. The light rays which fall on the reflecting surface of the concave mirror bounce off here in a point. The other light ray, incident ray, also bounce off here in the same point. The two arrows intersect each other in a point which is called focus or focal point. So the light rays which fall on the reflecting surface of a concave mirror converge and combine together and intersect in a point which is called the focus. But about the convex mirror, here is the incident light ray fall on the reflecting surface here, diverge. So it's called a diverging mirror. A diverging mirror. The light ray, incident ray, fall on the surface here, reflect and distribute away, not intersect with the other reflected ray, so diverge, all rays come and fall on it. So it's called, the convex mirror called a diverging mirror. Some important points and some definitions here you must know. If we imagine this sphere, here is the concave mirror, the reflecting surface from inside. This point is called center of mirror curvature. Center of mirror curvature. It is the center of the sphere. And here is for the convex mirror. It's the same point, it's called center of curvature. So C, it refers to the center of curvature. Center of curvature. What is the center of mirror curvature? It is the center of the sphere that the mirror is a part of it. The mirror is a part of it. It lies in front of the reflecting surface on concave mirror, while lies behind the reflecting surface in the convex mirror. As you see, in front of the concave mirror, C, and behind the reflecting surface of the convex mirror. Again, we can see R, as you see here, which is radius, the radius of the sphere, the radius of curvature of the mirror, the radius of curvature. It is the radius of the sphere that the mirror is a part of it, as you see here. As you see here. The pole of the mirror. Here is the pole of the mirror. It is the midpoint here. It is the point that is in the middle of the reflecting surface of the mirror, as you see here, in the middle of the reflecting surface. It's called the pole of the mirror. Again, C is for center of curvature, R, radius of curvature, P for pole of the mirror. The principal axis, CP, here is the line between C and P, is called principal axis. It is the straight line that passes by the pole of the mirror and the center of curvature. Here is the line CP. From C to P, it is the principal axis. What about the secondary axis? The secondary axis, it is any straight line that passes by the center of curvature C and of the mirror and any point of its surface except the pole of the mirror. Here is the principal axis between C and B. But when we draw a line from C to any point at the mirror, it's called secondary axis. Any point except P. Any point except pole. Because from C to P, from center of curvature to pole of the mirror, it's called principal axis. And to any point, from C to any point at the reflecting surface, is called secondary axis. Please, again, we can summarize these all points. C, center of curvature. R, radius. P, pole of the mirror. And from C to P, it is called the principal axis. From C to any point on the reflecting surface except P, it's called secondary axis. The focus of the mirror. When the reflecting rays, the reflected rays here comes from the reflecting surface, it will collect in one point, which is called focus or focal point. Focus. Light rays which come parallel from a distance object like sun are collected at one point by using the concave mirror. This point is called the focus of the mirror. What is the definition of focus of the mirror? The focus of the mirror is the point of meeting of reflected rays after falling on a concave mirror, or the point of meeting the extensions of reflected rays after falling on a convex mirror. We will see it in another slide. But here we can concern for the concave mirror the focal point in front of the reflecting surface here. As you see, the incident light rays come parallel from the sun and fall on the reflecting surface. Here is the reflected light rays come and collect in one point, which is called focus, in front of the reflecting surface of the concave mirror. Note this, the distance between the focus of the concave mirror and its pole is known as focal length. The distance here from F to B is called focal length. Okay, and it is equal half radius of curvature. It means F focal length equal half radius of curvature. Okay. Now, please notice the path of light rays on a concave mirror. When a light ray, incident light ray, strikes the concave mirror here, as you see, it will bounce off and pass through the focus, as you see here. When the incident light ray passes through the focus from the first exposure, as you see here, the light incidence here passing through the F, it will reflect parallel to the primary axis or principal axis. So when the incident light ray that passes through the focus reflects parallel to the principal axis, as you see here. The third case, when the incident ray passes through the center of curvature, as you see here, the red light arrows here, rays, it will reflect on itself. When passes through C, center of curvature, it reflects on itself. Again, three cases for the path of the light ray, incident light ray or concave mirror. When it comes parallel to the principal axis, it reflects and passes through F, focal or focus. When passes through focus, it will reflect parallel to the principal axis. When passes through center of curvature, it will reflect on itself. The formation of an image on a concave mirror. Please note this. When there is five cases, please pay attention to these cases. When the position of the object is very far, like the sun, very far, the incident light ray comes from a distant area, comes parallel to each other and fall on the reflecting surface of concave mirror. This bouncing of rays, the reflecting rays, comes and collected in the focus. Comes and collecting in the focus. So the properties of the image which is formed in this case is real and very tiny, dot-like. Real and very tiny, dot-like. This is the first case. Number two, when the position of the object at a distance larger than the radius of curvature. As you see here, this is the center of curvature, and the object put here, the length here or the distance here away from the center of curvature. The incident light ray will reflect in the focus, the first one, and another one which passing from through the focus comes parallel to the principal axis. These two reflected rays will intersect in a point. Here is the image will be formed in front of C, between C and F. So this is the case. The position of the object at a distance larger than the radius of curvature. The position of the image between the focus and the center of curvature, it is another one. Here is the position of the image between the focus and the center of curvature. Okay. The properties here, real, inverted, small or diminished image. The object here is the image, small, inverted, and diminished, as you see, but real. We can receive it on a screen. This is the second case. The third one, when the position of the object at the center of curvature, here is the object at the point of center. The image will be formed as the center, but inverted, but equal in size. Here is the image at the center of curvature, and the properties real, can received on a screen, inverted, as you see here, the image inverted and equal to the object, the same size. The fourth state, the position of the object between the focus and the center of curvature. As you see here, this is the object between C and F. The incident light ray, as you see here, and rebound passing through F, and another one passing through F, reflect parallel to the primary axis. The intersection between the reflected rays here make the image. As you see, real, can be received on a screen, inverted, as you see here, and enlarged, as you see the size here is bigger than the size of the object. Number 5. Here is the position of the object between F and B. F and B. Here is the object between F and B, closest to the reflecting surface of the concave mirror. What about this? The incident ray here, and will be reflected, as you see, and another one reflecting itself. So the extensions of these rays will be formed behind the reflecting surface of the concave mirror and forming virtual image cannot be received on a screen behind the reflecting surface, erect, as you see, and magnified. Again, virtual, erect, and magnified image. These all about the cases of the concave mirror. Uses of concave mirrors. What is practically used in? The concave mirror is converging mirror, as we talked before, so that it is used many purposes. For example, it is used as a torch to reflect light. When we use torch, the inner surface of the torch is a concave mirror to reflect light and give it for a distance. In shaving, to get an enlarged and erect image of the face. Also in marine lighthouses that are found at marine ports and at airports to guide ships. In aircrafts landing at airports to guide aeroplanes, also in solar ovens. Here are the uses of the concave mirrors. What about the convex mirror? Only one case here we will study for illustration also this image. All images formed on a convex mirror have the same properties, which are upright, here is the object, and the image. Upright, already upright. Number two, virtual, not real, behind the reflecting surface. Cannot be received on a screen. And smaller than the object, as you see, smaller than the object. This is the only case for the convex mirror will be studied. Convex mirrors used as side view mirrors on the passenger's side of a car because it forms an erect and smaller image, for the way behind the car. As you see, the image here for the road is smaller in size than real image, and you can see all road compartments here in the convex mirrors. It is suitable for convenient shop, big supermarket, and any other corner where it needs anti-thief. Also, it is used in the turning of the road. You turn here, as in the corners of roads, you can see all parts of the intersection of roads. Comparison between the real image and the virtual image, it is the final slide. We can conclude this. The real image and the virtual image. The real image, it is formed as a result of intersection of reflected light rays. So the reflected light rays here make it in front of the reflecting surface of concave mirror. But the virtual image, it is formed as a result of intersection of the extensions of the reflected light rays behind the mirror. The real image, it can be received on a screen, but the virtual one cannot be received on a screen. Number three, it is always inverted for the real image, but the virtual image, it is always erect or upright. Now we finish all about concave and convex mirror. Please keep in touch. If any question you need, keep in touch. God bless you.